Yo, what's good, guys? Today we're going to be going over some derivatives, actually. Um, and I'm just going to, first of all, kind of, these are all identities, just looking at this, like derivative and integral, these are all identities. You shouldn't even have to do any, real math outside of just remembering. You should memorize what these derivatives are. At least the derivatives. Maybe not the integrals, but at least the derivatives. So, first off, I'm just going to prove them to you. um, just by I'm gonna actually do the math and then find the answer just so that you can see exactly how and why they equal it. So with most of these, you can't just straight up integrate secant x or cosecant x or tangent x. You have to rewrite them in terms of sine and cosine x, because sine and cosine x have derivatives that we actually know and don't follow, um, you know, these. I guess in a way, you could say that sine x and cosine x are identities, but there is real math there that I might show later. It's definitely not easy though. It's more or less just like a system of like things that equal sine x, and then you take the derivative of them, and then it'll just equal back to sine x essentially. So yeah, or to cosine x or whatever. Okay, so it's a fraction, so you're gonna use quotient rule. So low d high minus high d low over low squared. So this is cosine squared x, and then this is negative sine squared x, but since it's a negative here, it's plus. You should know that this is a like Pythagorean identity, where this is equal to 1. So it's 1 over cosine squared x, which is equal to secant squared x. And that's the derivative of tangent is secant squared x. Okay, so secant x. So you should know that secant x is 1 over cosine x. And once again, for all of these, it's just going to be quotient rule. So low d high minus high d low over low squared. This is sine x over cosine squared x. So essentially, this is sine x over cosine x times cosine x. So sine x over cosine x is just tangent. Sine x over cosine x is equal to tangent. And then we're left with a 1 over cosine x. So that is just secant x. So there's that. And then cosecant x is just 1 over sine x. Let me write this in a different color. 1 over sine x. So once again, quotient rule. Low, that's a sine, that's an S, not a 5. Low d high minus high d low over low squared. So this is negative cosine x time over sine squared x. Negative cosine over sine is cotangent. So we have negative cotangent x, and then we're left with a 1 over sine x cosecant x. And that's the integral of cosecant x. So I hope you like this. Hope this helped. So thanks.